Okay, I just listened to the other one, or just started listening to a little bit of it. So my voice was pretty soft, so I'll try to talk a little louder. I think the problem is they have this, again, in our room we have this big fan or whatever, and it's blowing all the time. So the volume's a little soft here, so again, Screencastify is not working. This is the best we can do here. Okay, so 6.5 are the properties of special parallelograms. So let's just go through each. So a rectangle we define as a parallelogram with 4 right angles. Okay, and then it had one additional property with its diagonals. The diagonals were congruent. So in a rectangle, we defined it as a parallelogram with 4 right angles, and the extra property is that the diagonals are congruent. For a rhombus, that's a parallelogram with 4 congruent sides. And we had 2 extra properties here. The diagonals are perpendicular, so they form right angles in the middle, and then the diagonals bisect each of the opposite angles. So perpendicular, so 90 degrees all across the middle, and then they bisect the angles. So all 4 of these angles will be the same, and all 4 of those small angles there will be the same as well. We're splitting those big angles in half. Okay, and then a square has everything. It has all the things from a rectangle and a rhombus. It's both a rectangle and a rhombus. So since it's a rectangle, it has 4 right angles, and since it's a rhombus, it has 4 congruent sides. Since it's a rectangle, the diagonals are congruent. And since it's a rhombus, the diagonals are perpendicular, so you have 90 degrees in the middle as well. Okay, and since the diagonals bisect the opposite angles, right, and these are right angles, all the small ones here are going to end up being 45. So 45, 45, 45, 45, 45, and 45. All of those angles there end up being 45. All right. So let's go to the first problem here. All right, so we need to start by drawing. So we need to draw a rhombus out. So rhombus, ABCD is a rhombus. So let's just draw a rhombus, AB, CD. This pen in this room isn't the best either. But ABCD is a rhombus. Okay. The measure of angle, we want to also draw our diagonals. So diagonals AC and BD intersect at point E. So there's diagonal AC, here's diagonal BD, and they're going to intersect at point E in the middle. The measure of angle BAD is 68 then. So this angle here, 68. Be the whole angle. Well, if we look back a slide at the rhombus, we know that the diagonals are perpendicular. So we can put in our right angles in the middle here. We have 4 right angles in the middle, 90, 90, 90, 90. We also know the diagonals bisect those angles. So they split them bisect the opposite angles. So they split them in half. So half of 68 here is going to be 34, and then this one down here will also be 34. Those 2 smaller angles will be 34. BAE and DAE are 34. Right. Across from this one, this big one over here is going to be 68 as well, the whole thing. Right? Opposite angles are congruent. So this whole thing here is going to be 68. 68 there, the whole big angle there. All right, so if we split that in half, we're going to have again 34 and 34. 34, 34, 34. Let's do a light color here. So we want to look at this triangle. We know the 3 angles of a triangle add up to 180. So if we do 180 minus 34 minus 90, that's going to give us 56. You guys probably can't see that very well, but 56. 180 minus 34 minus 90, that'll give us this angle up here. Should be 56. and since diagonals are bisect opposite angles here, if this is 56, this piece here in our rhombus is also 56, and then these two down here are 56 and 56. From there, we just need to fill in the angles here. So measured angle CED, right, that's 90 degrees here. Right, so this one, I like how you can go back on the 90 degrees. No, I can probably draw it on the this. Yeah, so angle, no, not calibrated very well. But CED would be this angle here, which is 90. And this angle here, which is, it's not going to show up very well. Let's just do it with this. Okay, so CED here, right, 90 degrees. Okay, CBE, so here's C, here's B, here's E. So that's going to be this angle here, which is 56 degrees. ABC, so here's A, here's D, here's C. So ABC. So that's 56 plus 56, which is 112. Right? Degrees, angle is the degrees between the two rays that make it up. So it's that space there, 112 degrees. And then DCE, here's D, here's C, here's E. So that's going to be 34. And that's what a rhombus is going to look like every time. That pattern's the same. The numbers might change, but the pattern's the same. So it might be 33 and 57. It might be 22 and 68. But the pattern stays the same every time. Let's look at the next one, which is going to be a rectangle. Okay, so we can draw a rectangle EGFH. EFGH. I don't know the alphabet very well. EFGH. Okay, it's a rectangle, so you know you have right angles in the corners here. Diagonals EG and FH here are going to intersect at point J. Okay, if EG equals 3x plus 12 and FH equals 6x minus 18, find the length of HJ. Well, those are diagonals, and so if we go back a couple slides and we look at the properties for a rectangle, it's going to tell us diagonals are congruent. So we can set those two values equal to each other. So we can do, I'll do it over here so we have enough room for our Pythagorean Theorem here. But 3x plus 12 is going to equal 6x minus 18. Those diagonals are equal to each other, right? EG here is equal to FH. Okay, we subtract 3x from both sides. So we have 12 equals 3x minus 18. We add 18 to both sides. That's 30 equals 3x. Divide both sides by 3 and we get x equals 10. If we want to find the length of HJ, that's going to be half of FH. So if we substitute in for FH, so if we do 6 times 10 minus 18, right, x equals 10. So 6 times 10 is 60. 60 minus 18 is going to give us 42. Okay, so FH, the whole diagonal is 42. Right, EG is also going to be 42, right? We could check that. 3 times 10 plus 12, that's 30 plus 12 is 42. So our diagonals are 42. So HJ is going to be half of a diagonal, right? It's half of the diagonal. So 42 divided by 2 gives us 21. Scenario number 2. EH is going to be 8. JF is 8.5. So FH, the whole thing, is going to be 8.5 plus 8.5, which is going to be 17. And we're looking for the length of HG. Put an X there. Well, I know that rectangles have right angles, so I'm going to look and see if I can use the Pythagorean theorem. So I know that FG should be 8 as well. And now I have two sides of my right triangle. And I'm looking for the third, so we're going to use the Pythagorean theorem. So this is going to be a squared plus b squared equals c squared. So a and b are your legs, so 8 squared plus x squared equals your hypotenuse, which is c squared. Okay, a lot of you guys on the test, or a lot of you in the past, like, you just look for the numbers and set them equal to the x. So a lot of you guys have been doing 8 squared plus 17 squared equals x squared. The c is the hypotenuse, so it doesn't matter. C could be x or it could be a number, but you have to look at your diagram. Here's our right angle, so this is your hypotenuse. Right, so that has to be your c. Whatever your hypotenuse is the c. So it's equal 17 squared, not equal to x squared. 8 leg squared plus leg squared equals hypotenuse squared. 8 squared plus x squared is hypotenuse squared. Okay, and multiply those out, so that's 64 plus x squared equals 289. We subtract 64 from both sides. We get x squared equals 225. We take the square root of both sides. And right, we're doing the inverse of a square is a square root, so we take the square root of both sides. So x is plus or minus 15, but since we're only dealing with a distance, we only want the positive. So positive 15. So HG here is going to be a positive 15. Okay, 8 squared plus 15 squared equals 17 squared. Right, let me see if I can't erase some of this stuff. Maybe I should just redraw the whole thing, I don't know. Okay, here's our rectangle. Here's our diagonals. Point J is in the middle. The measure of angle FHG here is 22. 22 degrees right there. Since it's a rectangle, you know, all four of the triangles here are isosceles triangles. All four of those pieces are the same. So this is 22, this up here is 22. And then these two triangles we had shown were congruent by side angle side. So 22 and 22 and 22. Or you can think of it as alternate interior angles are congruent. We know we have right angles here. We know that these two angles should add up to 90 degrees because it's a rectangle. So we have a right angle. So 90 minus 22 is 68. And then this would be 68. 90 minus 22 is 68. 90 minus 22 is 68. So the measure of angle GEH is 68 right here. 68. So that's your rectangle. Okay. So we need to leave here, go to the next one. Alright, so we have a rhombus for this one. We need to find both sides, diagonals, angles, everything here. So it's a rhombus. So we know a rhombus is a parallelogram with 4 congruent sides. So AB is going to have to be 10. Right? All sides of a rhombus are congruent, so it has to be 10, right? 10, 10, 10, 10. AC here is 18. Right? AC here is 18. So since a rhombus is a parallelogram, all our properties of parallelograms still apply. So our diagonal is getting bisected. So AC is getting split in half by BD, so that's going to be 9 here and 9 here. So AB was 10. Now we're looking for DE, so we can put an X there. You want to look at this triangle. It's going to be a right triangle since this is a rhombus. diagonals are perpendicular, so we have a right triangle. And we can use our Pythagorean theorem. So a squared plus b squared equals c squared. So we're going to have x squared plus 9 squared equals 10 squared. Again, a lot of you guys will just do 9 squared plus 10 squared equals x squared, but it's length squared plus length squared equals hypotenuse squared. Okay, so that's x squared plus 81 equals 100. We're going to subtract 81 from both sides. So we have x squared equals 19. We can take the square root of both sides. And we're going to get x is approximately, if I remember, because I've already done this several times, because the video has failed several times, 4.4. But if that's wrong, double check it, but it should be 4. I think it's 4.35, which rounds up to 4.4. Okay, so EE is 4.4. This whole diagonal then would be 4.4 plus 4.4, which would be 8.8. Okay, so that's the sides there. All right, I'm going to erase and then we can look at the angles now. That was the sides and diagonals. Let's look at the angles now. Okay, we know the diagonals in a rhombus are perpendicular. If we look back a few slides at the properties, you have diagonals are perpendicular and the diagonals bisect the opposite angles. So if this one's 53, this one right next to it is also 53, because we're splitting that angle into two equal pieces, ABC. Angle ABC is getting split into two equal angles. So the ones down here are 53 and 53. Opposite angles are congruent, so if this whole thing's 106, this whole thing's 106, so 53 and 53. Okay, we have a triangle here. Right, 180 minus 90 minus 53. It's going to be 37. So this angle is 37, which means this one's 37, which means the ones on the other side are 37 and 37. Now we have all the small angles, we can just fill in our answers here. So measure of angle CED, C to E to D. Right, that's going to be this angle here, which is 90 degrees. And then BCD, so B to C to D. That's going to be this whole angle here. So that's going to be 37. It's the whole thing. B to C to D is this whole big angle. So 37 plus 37 is going to be 74. So the whole angle there is 74. The whole angle there is 74. And the big angles here would be 106. And then here would be 106. Question 8. We got 3 more here. Next one is also a rhombus. So we're starting again with sides that were diagonals in this case. We know a rhombus is a parallelogram, so we know diagonals bisect each other, right? We know that those two pieces and these two pieces are the same. GK is equal to KJ and FK is equal to KH, so the piece they're giving us is JK, 3x plus 1, and JK, x plus 9. So those are going to be equal to each other. That diagonal is getting bisected. It's getting split into two equal pieces. So we're going to have 3x plus 1 equals x plus 9. We can subtract x from both sides, so we have 2x plus 1 equals 9. We can subtract 1 from both sides, so we have 2x equals 8. Divide by 2 on both sides, so we get x equals 4. If we substitute that back in, we have 3 times 4 plus 1 is 13. 4 plus 9 is 13. So this piece is 13, this piece is 13. So GJ, the whole thing is 13 plus 13 is 26. JK is 13. Okay, and that's the diagonal there. So we want to now switch over to angles. So angle HFJ and angle HJF. So we're going to need to solve for y first. This angle here is y plus 4. That means this angle here is also y plus 4 because this is a rhombus. So diagonals bisect the opposite angles. So y plus 4 and y plus 4. So I think the easiest way, you could use the triangle. This whole angle is 4y minus 8. That means each individual one is 2y minus 4. So 2y minus 4 and 2y minus 4. So we could do 2y minus 4 plus y plus 4 plus 90 equals 180 and use the triangle, but I think it's easier to get the whole angle here and use the consecutive angles. So this angle here is going to be 2y plus 8. So 2y plus 8. And 2y plus 8. And so consecutive angles are supplementary. So if we do 2y plus 8 plus 4y minus 8, right, that should equal 180. Consecutive angles should add up to 180. So we combine like terms here. We have 6y, positive 8, negative 8 cancel out, and we get 6y equals 180. Divide both sides by 6. 6 goes into 18 3 times, and you have an extra 0, so 30. And now we can plug, substitute back in. So I'm going to erase this. Okay, y plus 4, that's 30 plus 4 is 34. So that means this one here is also 34. And then across down here are 34 and 34. 4y minus 8, so 4 times 30 is 120 minus 8 is going to be 112. So that's the whole angle is 112. So each one is 112 divided by 2. The diagonal is bisecting the angle in a rhombus. So that's going to be 112 divided by 2. It's going to be 56, right? Which means the ones down here are also 56 and 56. Okay, and in the middle, diagonals are perpendicular, so you have 90, 90, 90, and 90. So we're looking for HFJ. HF, so here's H, there's F, there's J. That's going to be 56. Right there, that angle is going to be 56. And then we're looking for HJF. So we're going from H to J to F. That's this whole angle. So it's the whole angle, so it's 34 plus 34 gives us 68. 34, 34 gives us 68. Right, and we knew this was 112 too, right? So 112 plus 68 should add up to 180. Right, that's, I think we have now a rectangle and a square. So next question, number 10, should be a rectangle. Right. Okay, MO. So we know this is a rectangle, rectangle parallelogram. So again, diagonals bisect each other. Actually, we know the diagonals would be congruent because it's a rectangle, and they bisect each other because it's a parallelogram. So actually, all 4 of those pieces are the same. But we know MP is equal to PO, so we can do 5A minus 7 is equal to 2A plus 8. Subtract 2A from both sides. So we get 3A minus 7 equals 8. We can add 7 to both sides. So we get 3A equals 15. And divide both sides by 3, and A equals 5. When we substitute that back in, we have 5 times 5 minus 7 is 18. 25 minus 7 is 18. And we have 2 times 5 plus 8. That's 10 plus 8 is 18. So good. We better get the same answer there. So 18 and 18. So that means MO is 18 plus 18, which is 36. And then LP is going to be 18 because these pieces are also 18 and 18 because this is a rectangle. And in a rectangle, diagonals are congruent. Alright, so LP is 18. Okay, LM. So I'm going to erase this so we have more room. So we're looking for LM. Okay, we have MN is 26. And we know LN is a diagonal, that's going to be equal to 36. So we have, again, a right triangle, because this is a rectangle, so all the angles in the corner are right angles, they're 90 degrees. So we have two sides of a right triangle, and we're looking for ML, or LM, which is our third side. So we have x squared plus 26 squared equals 36 squared. So x squared plus 26 squared equals 36 squared. Right, so that's x squared equals, plus 676, and I don't remember what 36 times 36 is, so we'll grab my phone. It was 1296. So we subtract 676 from both sides, and we end up with x squared equals 520 minus 676. 620, I'm sorry. 620. And then we can take the square root of 620, which is going to be 24.9, right? The inverse of a square is a square root. So take the square root of both sides. So x is going to be equal to approximately 24.9. So 24.9 squared plus 26 squared equals 36 squared. So 24. Right, and then last part of this one, angle NMO. So let's change this up and do the angles. Okay, so 24 here. We know all these angles are 90 degrees. Right, we also know all these pieces in the middle are congruent. So we have two different sets of isosceles triangles that are congruent. Four isosceles triangles, but two different pairs of ones that are congruent. This one and this one are congruent, and this one and this one. But 90 minus 24 gives us 66. Right, so up here you have 66. 90 minus 66 is 24. 24. 90 minus 24, 66. 66. And then 24. So NMO, get the blackboard now. NMO, that's this angle here, which is 24. If you can read it. 24, 24, 24, 24, then 66, 66, 66, and 66. So NMO is 24 degrees. 24 degrees. All right, the last one here is going to be a square. So a square is both a rectangle and a rhombus, so it has four congruent sides and four right angles. So we know all the sides are congruent, so all these sides are equal. So we can do 2x plus 7 equals 3k minus 2. 2k, not 2x, 2k plus 7. We can subtract 2k from both sides. That's going to be 7 equals k minus 2. We add 2 to both sides, and we get 9 equals k. If we substitute that in, that's 2 times 9 plus 7, which is 18 plus 7 is 25. 3 times 9 is 27 minus 2 is 25. So we have 25 and 25. We're looking for SU. So that's the diagonal. So let's look for the Pythagorean theorem, and there we go. We have a right triangle, so we can definitely use the Pythagorean theorem here. We're looking for SU. We'll put an X there. So 25 squared plus 25 squared equals X squared. Leg squared plus leg squared equals hypotenuse squared. So 25 squared plus 25 squared is x squared. That's 625 plus 625, that's 1250. I believe this was 34.9 or 35.4 or something like that. Let's see. Square root of 1250 is 35.4. So we take the square root of both sides, right? We have a square, so to get rid of the square, we have to do inverse, which is square root. And so we get x equals 35.4 is approximately x. So SU is about 35.4. That means our T is also 35.4. So RV is going to be half of that. So half of 35.4 is going to be 17.7. So each small piece here is going to be 17.7. And then let's look at the angles. Okay, so the angles here. Square is a rhombus and a rectangle. So since it's a rhombus, the angles in the middle are 90 degrees. So angle TVU is going to be 90. And since it's also a rhombus, the diagonals bisect the opposite angles. And we know since it's a rectangle, each of these angles is 90 degrees. So each of these is 90 in the corners. And since we're bisecting those 90-degree angles, we're splitting them in half. So each of these are going to be 45. So in every square, all of these angles here are going to be 45 to 45. So the angles of a square will never change. This will always be what a square looks like for the angles. So we're looking for VRU is going to be 45. And that's it for 6.5 here. We'll do one more for 6.6.